solve 2 to the x is equal to 8 raised to the x plus 2. So we have an exponential equation here we're trying to solve. And we'll notice that the left-hand side, the base is a 2, and the right side, the base is an 8. So if we want to use the uniqueness property, we need these bases to be the same. So sometimes we have to rewrite one side, sometimes we have to rewrite both sides. In this case, hopefully you can notice that 8 can actually be rewritten as 2 raised to the third power. So 8 is equivalent to 2 cubed. Therefore, if I just rewrite the 8 as 2 to the third power, then I will be raising that to the power of x plus 2. In the left-hand side, I don't have to do anything to the left-hand side because now my bases on the left and the right side are the same. So again, to use the uniqueness property, we want our bases to be the same on the right and left-hand sides of our equation. Now, on the right-hand side, we do need to use our one of our properties of exponents here. We have a power raised to another power, and we know, for example, off to the side here, if I were asking you to take x squared and then raise it to the third power, remember that's the same as x squared times x squared 3 times, so times another x squared. So if you're trying to think of this without using any sort of rules, just think logically, this ends up being x to the 6th power. So what I really was doing was multiplying my exponents. So I'm going to do the same on this problem. I'm going to multiply my exponent. So I'll have 2, and then when I multiply, this is going to be 3 times x plus 2, which is going to require me to distribute. So that would be 2 raised to the 3x plus 6 power. Now you'll notice the base on the left is the same as the base on the right, so now we can use the uniqueness property, which allows us to set the exponents equal to one another. So now we have x is equal to 3x plus 6, and my equation is no longer exponential. Now this is a nice straightforward linear equation. Subtracting 3x from both sides, and then dividing by -2 gives us an answer of x is equal to -3. You can leave it like this, or you could actually write it as my solution set. My solution set is the number -3. And then if you wanted to do a check, you certainly could. You could come back up to the beginning here and go ahead and input -3 for x, put a little question mark over the equal sign, and see if it will indeed give us the same quantity on the left and the right hand side as we input a -3 for x. So the left-hand side, 2 to the -3 power, is the same as 1 over 2 cubed, which will be 1/8 ultimately. And then we can check the right-hand side. We have 8 raised to the -3 plus 2, which would give us a -1 exponent. And again, 8 to the -1 power is 1 over 8. So it does check out. My solution is -3.